Okay, so now we're going to solve multi-step equations, and it's not as hard as it seems because the good news is you already know all the steps. So you already know how to solve by addition or subtraction, to solve an equation by adding or subtracting values from both sides. And you already know how to solve an equation by multiplying or dividing values from both sides. Now we're just going to put it together. Now, there are additional steps that you'll learn in the future, but for right now, it's just those two steps and how to do them. In order to be able to be successful, though, we have to put one more thing back into the mix, and that is, remember PEMDAS says that when you're simplifying an expression, so when you simplify, you work down PEMDAS. You do the parentheses first, then exponents, then you multiply and divide from left to right, and then you add and subtract from left to right. When you're solving, right? So when you're solving, and let me do it this way, you work up PEMDAS, right? So when you're solving, you're going to work up PEMDAS. That doesn't make it, there you go. And what that means is you want to change things, you want to move things across the equals sign by addition and subtraction first, finish all of that, and then move things across the equals sign by multiplication and division. So let's do an example. Nothing like an example to see what we're talking about. Let's solve for x, given that you have 2x plus 3 equals 9. All right, so we already know, and we're used to putting a line down our equals sign so that it's really obvious what we're talking about when we say side. This is the left-hand side, and this is the right-hand side of the equation. So what I want to do, solve, remember, just means to get the x all by itself and everything else onto the other side of the equation. That means I need to move 3 from the left-hand side to the right-hand side, and I need to move 2 from the left-hand side to the right-hand side. But the question is, which one to move first? Well, remember, PEMDAS backwards says to move by addition and subtraction first. So the question is, which number, 2 or 3, is connected to the variable by addition or subtraction? Obviously, it's 3. 2 is multiplied to x. 3 is added to where the x is. So that's the one we want to move. We're going to move by transposition. I'm going to subtract 3 from both sides, and that means this disappears. So let's clean it up. The 2x is all that's left on the left-hand side, and on the right-hand side, I can do a little bit of arithmetic. 9 take away 3 is 6. Done. So I've done the addition subtraction. Now I'm going to move on to multiplication division, because the only thing still connected to the x is a 2, and the 2 is connected by multiplication. What undoes multiplication? Division. So I'm going to turn a multiplied 2 on the left-hand side to a divided 2 on the right-hand side, and when I divide 2 by 2, it just equals 1, and so I can cancel it. Clean it up. X equals 6 divided by 2 is 3. So I think the solution to this equation is x equals 3. Remember, we have a way to find out, and remember, I like you to make this loop with the arrow. That tells me that you're going to check by plugging that 3 back into the original. So let's write the original out. 2x plus 3 equals 9. And we want to know, does 2 times 3 plus 3 equal 9? And it's a question right now. We don't know yet. We haven't proven that it does. 2 times 3 is 6 plus 3. This is looking good for us. 6 plus 3, 9 equals 9. Since this is true, I can say yes. X equals 3 is the correct solution for this x value in this equation. Good golly, that was fun. Let's do another one. We want to solve y divided by 4 minus 2 equals 1. Okay, left-hand side, right-hand side. Y is the variable that we want to get all by itself, which means I need to figure out a way to get this -2 to the other side and a way to get this 4 to the other side. Which one do I want to move first? Well, y is connected to 4 by division, but y is connected to 2 by addition subtraction. So I'm going to move the -2 first because that's what my algorithm, PEMDAS, says when I'm solving, I have to work backward. So I'm going to add 2, a -2. The way I make that disappear, -2 plus 2 becomes 0, is to add 2 to both sides. Write it on this side first, so I don't forget what I'm doing. Add 2 to both sides, which makes this one disappear. Now I'm just going to clean it up. Y divided by 4 equals 1 plus 2 is 3. Now I want to move the 4. How is 4 connected to y? By division. What undoes division? Multiplication. So I'm going to multiply both sides by 4, which means this 4 is going to disappear. Because if I multiply this side by 4, I get 4 divided by 4. 4 divided by 4 equals 1, and that's the same thing as writing 1y, which is exactly the same thing as just writing y. So y equals 3 times 4, which is 12. Check our answer. Write the original. Y divided by 4 minus 2 equals 1. Instead of y, I'm going to write 12. 12 divided by 4 minus 2 equals 1. And we're not sure if that's true, so because we're checking. And now remember, now I'm not actually solving because I already have numbers for all my values. I plugged in 12 for y. I'm simplifying, so I'm going to go back to PEMDAS down, which means I have to do the multiplication and division first. 12 divided by 4 is 3, minus 2 equals 1. 3 take away 2, 1 equals 1. That is true, so I can say that y equals 12 is the correct answer or is the solution for this equation. Let's do another one. 9 minus 6a equals 45. All right, 2 sides. Left-hand side, right-hand side. The variable is on the left-hand side, so I know I need to move a -6, because that's a -6, and a +9 to the other side so that a is alone. Which one do I want to move first? Well, PEMDAS backward, the addition subtraction. Which number is connected to the variable by addition and by which is connected by multiplication or division? Sometimes it's a little tough to tell because this is -6a and it looks like 9 isn't connected at all. You have to kind of visualize that you're talking about sort of proximity, not actually connected like with glue. So the 9 isn't close to the a, like this 3 was right next to the x, and this -2 was right next to the y. But this 9 isn't exactly next to the a, but it does mean that the thing that is separated from a by addition or subtraction is this 9. It's a +9 on this side, and we want it to be a -9 on the other side, right? Because we want to get rid of this +9. So I'm going to subtract 9 from both sides. +9 take away 9 equals 0. And now clean it up. -6a equals, my a's always look like 9s. Let me see if I can do a better job of that. -6a equals 45 take away 9. Well, 45 take away 5 equals 40. So if I take 5 from the 9, I'd be at 40. 4 more from the 9 takes me to 36. I'm jumping ahead. I'm sorry, I'm doing some work in my head. That's not good. Now I've moved the addition subtraction part of the problem. Now I want to move by multiplication division. How is -6 actually connected to a? Well, it's multiplied to a. So I want to turn a multiplied -6 on the left-hand side to a divided -6 on the right-hand side. That means it disappears on this side because -6 divided by -6 would be 1. That would leave me with 1a, so I would just write a. 36 divided by 6 equals 6. A positive and a negative is a negative. So a equals -6. Let's check it. 9 minus 6a equals 45. I'm going to put in -6 for a. 9 minus 6 times -6 equals 45. 9 plus 36. A negative times a negative is a positive. 6 times 6 is 36 equals 45. And 36 plus 9, if I use my fingers, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Wait, what did I just do? 36. Oh, yeah, 45. 36 plus 9. I'm not used to counting on my fingers. I got lost. 45 equals 45. That's a true statement, so A equals -6 is our right answer. See how my problems look neat and tidy and orderly? They don't have to be in color to be able to see what is going on. Oh, look, I had an original problem. I used transposition to solve for the variable. I checked to see if my answer is correct. My answer was definitely correct, and so I put a box around it so I know that's the final answer that I'm reporting. So that's it. That's all there is to it. Now that you can solve by adding and subtracting, I should do it here, adding and subtracting, and you can solve by multiplying and dividing, you can now solve using PEMDAS backward when you have both in your original problem.